a 250 milliliter flask, a 500 milliliter flask, and a 1,000 milliliter flask. We will take the 125 milliliter flask and place it in a boiling water bath. We will wait for a few minutes so that the gas inside the flask reaches the same temperature as the boiling water bath. The gas inside the flask, which is air, will expand as it's heated. When the air inside the flask comes up to the same temperature as the boiling water bath, there will be just enough air in the flask to fill the flask at the boiling point of water. I will put my fingertip over the tip of the glass tubing in the rubber stopper to trap the air in the flask. I will then quickly invert the flask in the tank of water and allow the gas to cool. As the gas cools, atmospheric pressure will push water up into the flask. Eventually, the air in the flask will come to the same temperature as the temperature in the large water bath. We will raise the flask so that the water level inside the flask and outside the flask are the same. This means that the total pressure in the flask will be the same as atmospheric pressure. I will now put my finger back over the tip of the stopper and remove the flask from the tank. We will carefully remove the rubber stopper from the flask and pour the water into a graduated cylinder. The volume of the water in the cylinder is 26.5 milliliters. We will now fill the flask completely with water. The volume of the water that completely fills the flask is the volume of the air that filled the flask at the temperature of the boiling water bath. We will now measure the volume of the water that is necessary to completely fill the flask. The volume is 138 milliliters. The difference between the volume of water required to completely fill the flask and the water that was in the flask after cooling is the volume of the air at the temperature of the large water bath.